Welcome back to The Explainer. Today, we are treating the Cambridge 9618 Computer Science exam like the ultimate casino vault, and we're assembling a team of cognitive specialists to pull off the perfect answer heist. I call this the examiner's playbook. We are going to decode exactly what it takes to master a topic that literally makes or breaks your grade, implementing cues using arrays. Think of this as your master blueprint. If you want to know how the people grading your papers actually think and how to outsmart the system to secure every single method mark, you are in exactly the right place. Let's get this operation started. Okay, let's dive right into the stakes here. Take a look at this. This single topic, implementing cues using arrays, accounts for a massive 15% of your total paper 2 marks. Just let that sink in for a second. 15%. Historically, candidates drop tens of thousands of potential marks globally right here simply because they underestimate the rigor required by the examiners. This isn't just some minor footnote at the back of your syllabus. It is a major high-stakes battleground. If you can master this one payload, you're effectively securing a massive chunk of your grade before you even step foot into the exam hall. It's the ultimate target for our heist. Here is the clear, step-by-step roadmap for our operation today. First, we'll cover the Paper 2 stakes and look at why some students fail right out of the gate. Then, we move to core theoretical principles. After that, we break down the procedural framework. Next, we review the top 3 examiner warnings to ensure you don't trigger any alarms. And finally, we'll secure the bag with critical evaluation and analysis. Section 1. The Paper 2 stakes. Let's look at exactly what cognitive skills are being tested here. It all comes down to a crucial balance, and to explain this, I want to introduce you to 2 archetypal students, Alex and Sam. Alex comes in hot, completely overloading their answers with raw computer science facts. They know the textbook definition of an array and a first-in, first-out queue, but there's zero analysis. On the other hand, we have Sam. Sam rushes in, completely misses the command word requirements, and just starts writing pseudocode with no structure. Both of their papers end up covered in red pen marks. Why? Because look at the right side of this screen, application and analysis. The examiners explicitly state their assessment objectives target these higher, distinct cognitive domains. Just memorizing what a cue is won't cut it. You have to apply that theory to the specific scenario they give you. You need to decode the command words perfectly. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Section 2, Core Theoretical Principles. Let's see how we transform those red pen marks into green check marks. Listen to this exact quote straight from the principal examiner reports. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Cambridge isn't going to just ask you to program a queue in a blank vacuum. No, they will give you a totally unfamiliar context. Maybe it's a digital conveyor belt for an airport luggage system, or a print spooler for a busy office network. This is where Alex goes wrong. You can't just drop textbook facts. Furthermore, the reports highlight that candidates who reference cross-topic connections, like linking that luggage queue back to processing efficiency or memory management, achieve significantly higher marks. Your knowledge has to be an integrated, living web, not just a list of isolated facts. Section 3, the procedural framework. This is the core methodology of our perfect answer heist. To secure those method marks, you must demonstrate true algorithmic thinking. It isn't just about writing a giant block of code, crossing your fingers and hoping it works. It requires step-by-step decomposition. To execute this, top students use what we call the PEEL framework: point, evidence, explanation, link. First, you make your point about selecting the appropriate data structure. Then, you provide evidence through your efficient code implementation. Next, you offer an explanation of your logic, like why you chose a circular queue over a linear one. And finally, you link it back to the specific context, like that airport luggage system. Even if your final code has a tiny syntax error, showing this algorithmic thinking process through PEEL is how you scoop up all those highly valuable method marks. This builds into a beautifully standardized sequence. Face a queue implementation question? Follow these 5 steps without fail. Step 1. Identify the key elements from the prompt. Step 2. Apply the relevant principles. Decide if you need a linear queue or circular queue so the array doesn't artificially run out of space. Step 3. Execute with incredibly clear working. Write out your front pointer and your rear pointer explicitly. Step 4. Verify the results by mentally tracing your algorithm. Do a dry run. And step 5, present it in the appropriate format, using correct Cambridge terminology. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, Top 3 Examiner Warnings. This is the interactive workshop phase of our explainer. Time to navigate the minefield. I want to run a quick drill with you. Think about Sam and Alex. With all the endless hours of studying students do, why do candidates consistently lose marks on this topic year after year? What is the fatal disconnect between knowing the material at home and executing it in the exam hall? Let's find the flaws that trip the security alarms. The examiner reports pinpoint 3 specific fatal errors. First up, vague technical details. Examiners